part 2 of this hardest questions in the CIE AS level pure maths paper 1. Here we're going to do another 4 questions, and you can see those here. This is the question 1 we're first going to be tackling, question 2, question 3, and question 4, all worth quite a lot of marks there. So, and I'll put timestamps for those questions in the description and a link to this answer sheet which has all my answers to those 4 questions, but we're going to run through it anyway. So let's just get straight into it and start going through these questions. I highly recommend taking my exam hack series before doing this, because that'll give you an absolutely incredibly deep understanding of this exam, and this is just sort of like the icing on the cake. Anyway, let's jump right into it. So with this first question, we're given this equation, y equals x cubed plus px squared, where p is a positive constant. Show that the origin is a stationary point on the curve and find the coordinates of the other stationary point in terms of p. Well, you've seen this a lot. Stationary points occur when, or at, when sounds good. When dy by dx equals 0. Well, let's find our differentiation of this curve. And dy by dx of this curve is going to equal to 3x squared plus 2px. And so we need to figure out, where does that equal 0? Well, we get 3x squared plus 2px equals 0. And now if we factor out x here, we get 3x plus 2p equals 0. Well, one of our solutions will be when x equals 0. And another one of our solutions will be when 3x plus 2p equals 0, which gives us x equals minus 2p over 3. So we've got 2x solutions there. And then if we substitute this x equals 0, so this stationary point, back into our curve to get the y, we can see that we're just going to get y equals 0. So that's there shown that one of the stationary points is the origin. And now it wants us to find the second one. So we simply just plug the x value into our y. So we get minus 2p over 3 cubed, and then px squared. So plus p minus 2p over 3 squared. So this gives us a 8p cubed over 27 plus it'll be a minus, plus a 4p squared times p will be cubed over 9. And if we times both those two, 27, we can rewrite this like 12p cubed over 27, and then just add these two together, we get 4p cubed over 27. So that's the y coordinate. So our stationary points are at 0, 0, and at minus 2p over 3, comma 4p cubed over 27. Cool. So that's number 1. That's that's I done. It says then find the nature of these stationary points. Well, you would have seen this a lot again. To find the nature, well, we have to find the second derivative. And that's going to equal, well, our first derivative is 3x squared plus 2px. So our second derivative will be 6x plus 2p. Right? Times down by the power. And times down by the power, and go down a power. So that's that. And then if we want to figure out the nature of these stationary points, well, we just substitute in our x value. So the nature of the stationary point 0, 0 is where x equals 0, which gives us 2p. And because p is greater than 0, that means that 2p will also be greater than 0. So therefore, the stationary point at 0, 0 is a minimum. So it's a minimum stationary point. And so the other one will clearly be a maximum, but we can just test that at this 27. So let's plug that into our second derivative. So x equals minus 2p over 3. Well, let's sub that in. We get 6 times minus 2p over 3 plus 2p. And that gives us minus 12 over 3 is minus 4p plus 2p equals minus 2p, which is less than 0. So therefore, the stationary point at minus 2p over 3, 4p cubed over 27, is a maximum. Awesome. Okay, so that's that one done. That's already 7 marks in the bank. Just bank that in. And then we've got to do another, we've got another curve has the equation of this. So let's write that down. So I, the equation has the, I think it was this. Was that what it was? Let's just double check that. Yep. So find the set of values for P for which the curve has no stationary points. And I really love this question because it touches a lot of intuition. So it really tests your understanding. So where does this curve have no stationary points? Well, we know that stationary points occur at or when dy by dx equals 0. Well, that is when, so our dy by dx here is 3x squared plus p plus 2px plus p, when that equals 0. So our stationary points occur for the solutions of this equation. Now, if we want to find where this curve has no stationary points, we have to find where this equation has no solutions. And where does this equation have no solutions? Well, it's when our discriminant is less than 0. So, wherever our discriminant is less than 0 means that this equation has no solutions, which means that this curve has no stationary points. Okay, so that's like 3 levels deep, you know? That's good, I like it. So let's plug this in here. So we get 2p squared minus 4a, which is our 3, times p. We want to know where that's less than 0. So that's 4p squared minus 12p is less than 0. So let's find out where the solutions to this curve is. Well, we can divide through by 4 as well to give us this. So let's find the solutions. P minus 3 equals 0. So we have solutions at p equals 0 and p equals 3. So if we look at our curve, which will look something like this, and we can say this is the p-axis. Well, and this is our p squared minus 3p. So we want to know where is our p squared minus 3p less than 0. Well, it's less than 0 because this is 3 and this is 0 and this is 0. It's less than 0 here. So between these two values. So our p squared minus 3p is less than 0 when p is between 0 and 3. So your answer is that when p is between 0 and 3, your curve has no stationary points. So when your p is between 0 and 3, that means that your dy by dx has no solutions when it equals 0, and that means that your curve has no stationary points. That's a really good question. Okay, so that's question 1. Let's move on to question 2. So this is giving us a diagram here, in which we've got some lengths and we've got a triangle, and it wants us to find the area of this shaded region. Well, right off the bat, I can just say that the area of this shaded region is equal to the area of this triangle minus the area of, let's call this, we can call this 1, 2, and 3. Area of our first sector minus the area of our second sector minus the area of our third sector. So this big triangle minus the area, the sum of these areas of these sectors. So all we have to do is find these components out individually. So why don't we just start with the triangle here. So the triangle, so the area of our triangle is half base times height. And this is a right angle triangle. And I'll tell you why I know that is because I can see here that the length, so let's look at this triangle, we just rotate it. This is A, B, and C. This length here is 4, this length here is 3, and this length here is 5. So any triangle with the ratio of its sides as 3, 4, 5 is a right angle triangle. And that's how you know it's a right angle triangle, because it's the ratio of the sides of 3, 4, 5. So the area of our triangle is half base, which is 4, times height, which is 3. So that's just half of 12, which is 6. Okay, now let's work out these sectors. So A1, well, to work out the area of a sector, we know the area of a sector, the equation is half r squared theta, where theta is in radians. So for this sector 1 here, we want to find this angle. We can call this angle, let's call it theta A. We'll call this angle theta B, and we'll call this angle, we already know it, is pi over 2 because it's 90 degrees. So our theta, so we can work this out from the triangle. We know that sine of theta A equals opposite, so which is 3, over hypotenuse, which is 5. So this equals 3 over 5. So therefore our theta A equals the inverse of 3 over 5. And we can do the same for our theta B, because we're going to need these angles, which will be 4. Theta B will be opposite over hypotenuse, which is 4 divided by 5. So therefore our theta B equals the inverse sine of 4 over 5. And I'll do the calculation in the end, but that means that the area of our sector 1, so this sector, is going to equal to half r squared, and the r squared in this case is 3, the radius of the circle, because these are at the centers of these circles. So the radius is 3, so half 3 squared times our theta B, our theta A, which equals half of 9, so this is 9 over 2 theta A, and the sector 2 is half times 2 squared theta B equals 4 over 2, which is just 2 theta B. And finally our third one is half, and this is just the radius is 1, so of 1 squared of our theta C, which in this case is just pi over 2, is 1, well that's going to equal to pi over 4, right? So therefore the area of our shaded region is simply 6, the area of the triangle, minus 9 over 2 theta A minus 2 theta B minus pi over 4. And then you simply just plug in these values, and we can work out those values. We can put that in the calculator. You can just put this in the calculator. I calculated it before this, so I didn't have to do all this. Minus 2 times our theta B, which is the inverse of sine 4 over 5, and then minus pi over 4. And if you put that in your calculator, you're going to get a shaded region of I got 0.46. Okay, so yeah, the best advice for that is just work out each component individually and take your time with it. Okay, well, I left a lot of space. Okay, the next question is this. So we have a point. So we have this point, which has variables x and y, and is moving along a curve. And I always like to just, write everything out so I know what I'm doing, in such a way that the rate of change of y is constant. So they're saying that this point is moving along this curve in such a way that the dy by dt is a constant. Let's call it k. Find the values of x at the points at which the rate of change in x is equal to half the rate of change in y. So we need to solve when the rate of change in x is equal to half the rate of change in y. Well, we know that that is k, so this is just equal to k over 2. So therefore dx by dt equals k over 2. And we know an equation from our chain rule. We know that dy by dt equals dy by dx times dx by dt. Well, if we substitute all these things in, let's find our dy by dx. So dy by dx equals 2x minus times by 3 down here will give us 10 over 2, which is 5. X go down by a half, plus 5. So if we substitute all these things in to our equation here, our chain rule, we get k equals our dy by dx, which is 2x minus 5x to the half plus 5, times our dx by dt, which is k over 2. And then if we solve this equation, we're then solving, we're finding the values of x for which this is valid. So these k's will cancel, and we can times by 2, so we get 2 equals 2x minus 5x to the half plus 5. And then if we take this over, take the 2 over, we get 5x to the half plus 3 equals 0. Well, now we can substitute, we can do a substitution to work out this x. We can say that u equals x, u equals x to the half, right? If we make that substitution, then we get here, well, 2u squared minus 5, because you can see that u squared will equal x, right? Minus 5u plus 3 equals 0. And then we can solve for u and then find x. So we can do u equals minus b, which is plus 5, using our quadratic formula. 25 minus 4, 2, 3, all over 2, 2. So this equals, and this plus or minus. So we got 5 plus or minus the square root of 25 minus 8 times 3 is 24. So we got 25 minus 24 is 1. Square root of 1 is 1 over 4. So this gives us two solutions. We get u equals 6 over 4, which is 3 over 2. And we get u equals 4 over 4, which is 1. So we get x equals, because remember u equals x to the half, so this is x to the half equals 3 over 2, and x to the half equals 1. So we get x equals 1, and if we square both sides, we get x equals 9 over 4. So those are our two x values for the points at which the rate of change in x is equal to half the rate of change in y, where the rate of change in y is a constant for a point moving along this curve. Okay, and I think we've got, so that's 3, and then we've got one more question to do here, and that will conclude this video. Okay, so let's do this one. So we've got 3 points, A, -2, -1, B, 4, 6, and C at 6, -3. It asks us here to show that the triangle ABC is isosceles and find the exact area of this triangle. Well, a triangle is isosceles if 2 or more of the sides lengths are, look how terrible the handwriting is, are equal. You know what I mean though. Okay, so let's just find the lengths of these sides, like the length of AB. Well, this is going to equal to the square root. Remember, this formula is on your formula sheet, and watch my recent video, geometry, the exam hack for the geometry question. This is equal to 4 minus -2 squared plus 6 minus -1, 6 minus -1 squared. And there's no shame in just writing this out so you don't make a stupid mistake. This is equal to 4 minus -2 is 6 squared, and 6 minus -1 is 7 squared. So that's 36 plus 49, which is the square root of 85. Let's do AC. And this will be, so we get 6 minus -1. AC will be 6 minus -2. See, look, I almost made a stupid mistake. 6 minus -2 squared plus -3 minus -1. So -3 minus -1 squared. And that equals the square root of 8 squared plus 2 squared, -2 squared, which is 2 squared the same. You can write it like that. So that is 64 plus 4, which equals the square root of 68. And then finally, so this one, if it's isosceles, then this one should be the same length of one of these two. So BC is the square root of 4 minus -2, 4 minus -2 squared, plus 6 minus -1 squared. So 6 minus -1 squared, which equals the square root of 6 squared plus 7 squared, which is the same as this, which is the square root of 85. So, as AB length equals BC length, which both equal square root of 85, ABC triangle is isosceles. It's an isosceles triangle. Okay. And then it also wants us to find the exact area of the triangle. Well, let's think of this triangle like something like this. Let's draw it better than that. Let's think of it something like this, where you've got your A, your B, and your C, where your A, B, and BC are the same, so these lengths are the same. 85 and the square root of 85. And the bottom length here, and we'll call this H, the height, because we know that the area of our triangle is going to equal to half the base here, which is the square root of 68 times the height. So half the base times the height. Well, we need to find the height, and the height can be found, well, as this length here is obviously square root of 68 over 2, and we know that A squared plus B squared equals C squared, and our C squared is 85, square root of 85, so get the square root of 85 squared, and our B squared can be the square root of 68 over 2, square root of 60, square root of 68 over 2 squared, and then A squared can be our H. It's just a right angle triangle. This is Pythagoras' theorem. So this is H squared. So we can solve for h. So we get h squared equals 85 minus 68 over 4. 68 over 4, which is what? 68 divided by 4 is, let's do it on the calculator really quick. Let's get this calculator up. So we'll just do 68 divided by 4 equals 17. So we get 85 minus 17, which is 68. So h equals the square root of 68. So therefore the area of our triangle, the exact area, is half base, which is 68, square root of 68, times height, which is also the square root of 68. So that's your answer. And finally, so II, the point D is a point on AB such that CD is perpendicular to AB. So let's just visualize this. So we have A and B, AB. There's a point D on this line, and is such that CD is perpendicular to AB. So we've got CD, and this is C. Calculate the x-coordinate of D. Well, the x-coordinate of D will be the intersection between AB and CD. So we've got A, B, and some D point, which we don't know, and we've got our C down here. And these are perpendicular to each other. So C is at, what are our points? So -2, -1. So A is -2, comma -1. B is at 4, 6, and then 6, -3. So this is at 4, 6, and this is at 6, -3. So D, the x-coordinate, x-coord of D, this occurs when the line, so line AB intersects line CD. So all we have to do is find the equation of the line of AB and the equation of the line of CD, and then equate them to find the x-coordinate of D. Well, we know that the gradient of AB is going to be 6, so 6 minus 1, 7 over 4 minus 2 is 6. So therefore the gradient of CD, because they're perpendicular to each other, is -6 over 7, which is the negative reciprocal of the gradient of AB. So from this, now we have a point on both lines and the gradient of both lines, so we can find the equation of AB, which is y minus y1, which is +1. So we're taking A as our point. And then our gradient is 7 over 6 of x minus x1, which is +2. So we get y plus 1 equals 7 over 6 x plus 14 over 6. So then we get y equals, we're taking this over, plus 14 over 6 minus 1, and we can write this -1 as 6 over 6, which gives us 7 over 6x plus 14 is 8 over 6 y. And then we can rewrite this times through by 6, we get this. So that's the equation. So this is the equation of AB. And then we can find the equation of CD, which is y minus y1, which is +3, equals, the gradient is -6 over 7, and then x minus 6 times x minus 6. So we get y plus 3 equals -6 over 7x plus 36 over 7. So we can then take the 3 over, plus x plus 36 over 7 minus 3, which is the same as saying -21 over 7, so I can actually figure this out. 9 and 6 is 15, so it's 15 over 7y. So that's the equation of our CED. So therefore, we just substitute our y here into here to find the x coordinate of our d. So we get 6 times minus 6 over 7x plus 15 over 7 equals 7x plus 8. 7x plus 8. So let's just times in. So we get minus 36 over 7x plus 6 times 15 is 90 over 7 equals 7x plus 8. Now times through by 7. You get 49x plus 7 times 8 is 56. So that gives us, we take this over, we get an 85x, and then take that over. So we take that over, we get 85x on this side, and we take this over, we get 434. So therefore our x equals 34 over 85, which is 2 over 5. So the x coordinate of D is x equals 2 over 5. And that concludes this video. So we went through those questions, all these questions here, and I'll put the answer sheet in the link in the description. If you found this video valuable, please like and subscribe and give me feedback so I can improve my videos in the future. And make sure you watch, if you're taking this exam, make sure you watch my exam hack series. That will really get you the good grades that you're seeking. Anyway, that's all from me, and I'll see you in the next video.